Okay, in this lab, we are going to combine a lot of the things that we've learned so far to solve an open-ended case. So here we have a fictional company, Superior Research LLC, and they want us to build them a network. So we've got 3 buildings. Let's say they're all within 100 meters of each other, and there's 3 different kinds of employees. We have administration, accounting, and research. So there's an administration building, an accounting building, and a research building. They want to route information between these 3 buildings. So, conveniently, they've got a Cisco 2960 switch and a Cisco 1941 router for each building. That just so happens to match the equipment that we've been using so far in this class. Now, each building should have its own local area network, and they should be able to communicate with the other buildings. No internet access is required, only wired connections are required. So each building has about 15 employees, all in a single floor, so that makes the physical layout easier. The company is planning to expand into a 4th building, so they want the network to be flexible, so that adding a new network does not cause a burden for our network administrator. So we have to design and implement this network. Already given to us is a rough outline of the physical connections that should exist. Here we've got 3 routers, 1 router in each building. That's fairly typical. Every router is connected to a switch, and then we've got computers connected to those switches. We're not given any IP address information though, and we're not told exactly what to choose as far as configuration. So we have to figure that out on our own. Now, let's look at some of the hints in here that might guide us. We know that they want to expand and that they don't want to cause a big burden on the network administrator. So for a routing protocol, I would probably choose OSPF here instead of static routing. So that's one decision I would make. Now they want administration, research, and accounting to be separate local area networks. That means I have to come up with a subnetting scheme that will put each building on its own local area network. Now I also have to come up with an IP addressing scheme for the router connections. So how many networks, how many local, how many subnets do I need here? Looking at this diagram. Pause the video, think about it. The answer is I will need 6. I need the administration, research, and accounting local area networks. I also need small subnets connecting the routers. So I have to come up with a scheme that's going to make this make sense. So for the solution design, how am I going to connect the switches to the routers? I will use the uplink ports on my switches to connect to the routers using Gigabit Ethernet. Usually we would use a fiber connection to connect the routers. We're pretending that this serial cable can stretch and that we own the dirt between these buildings. That's okay. I'll come up with an IP addressing scheme, and I am going to use dynamic routing. So I need to just basically build the network. There's no instructions specifically telling me what to run. You should be able to use the previous labs to figure this out. So let's start. I'm going to just physically cable this, put my hardware on my workspace. So I'm going to call this router. And it's booting. I just want to change the display name. I'm going to call this router, instead of R0, R1, R2, etc., I'm going to call this R-admin. So the router for the administration building. I'll call this one R-accounting. I'll call this one R-research. So again, that's just for the display. That's just for helping me maintain an organized workspace and packet tracer. That didn't actually change the router's configurations. I'm going to need some switches. Let's throw our switches on there. I'll try to match the diagram. Still booting. While those switches are booting up, I'll go ahead, power off my routers, add those serial connections, power it off, drag the physical connection on, power it on, admin, physical, power it off, drag the serial connection on, turn it back on. So switch 2, I'll call this one S admin. I'll use that for my host name too when I get into configuring it. S accounting and S research. I'll add my end devices. I'll just put 1 PC per network just to do testing. These will be used to, I'll use these just to make sure that routing and everything is working. I'll call this PC admin, PC research, and I'll name this one PC accounting. Make that a dash instead of an equal sign just to be consistent. Okay, so I've kind of got my accounting building, my research building, and my administration building. I at least have the hardware in there. My hardware is booted up. Oh, that's good. I need to connect the cables now. So I'm going to use this lightning bolt, go to my connections. I never use the automatically choose connection type, just no. So I'm going to use copper straight through. This is my Ethernet cable. I'll connect fast Ethernet to, it does not really matter where I connect this. I'll just choose interface 01. I'll be consistent. I'm just going to connect interface 1 on each one of these. So my PCs are connected to my switches. I've got to connect the switches to the routers. I'm going to use the gigabit 01. That's my, that and 02 are my fastest interfaces. So I'll connect that to gigabit 00, and I'll just be consistent. Keeping the pattern going is a good thing. So G01 to G00. Now I'm going to connect my routers using serial cables. So I'll go 000 to 000. It doesn't really matter which end is the DCE side and which is the DTE, as long as I know what it is. It doesn't really matter which interface I plug it into, as long as I keep track. And Packet Tracer is nice because it's keeping track for me. Okay, so this is good. I've got my hardware physically laid out and it's physically connected, but now the next thing I should do is come up with an IP addressing scheme for this. Now there are many, many different correct solutions that I could come up with. I am going to make the executive decision that on my network, I'm going to use the 10.0 network for the local area networks in each building. And I'll use different 192.168 networks to connect the routers. So I'm just going to put a text box here. I'll say for this network, I'm going to use 10.0.1.0/24. So that's my network. Everyone in the administration building is going to be on that subnet. I'm going to use 10.0.2.0/24 for research, and I'm going to use 10.0.3.0/24 for my accountants. Now by convention, for G00, I'll use 10.0.3.1/24. So that's going to be the IP address for my router G00 interface. So that's going to be the default gateway for all my PCs. Now for this accounting computer, what IP address could I use? I can use anything in the 10.0.3. Now here, I can use anything between 2 and 254. I'll say 5. It would be /24. I have to use the same subnet mask. Now I don't need to put any IP addresses on my switch interfaces. For my research PC, I'll use 10.0.2.5/24. And for G00, I'll use 10.0.2.1/24. Now for my admin PC, I'll give that one 10.0.1.1/24. And G00, I'll give that 10.0.1. No, I need to give that 1.1/24. I need to give my PC the .5 address. And sometimes selecting this is super annoying. But there we go. Correct that. So all my PCs are something .5. The internal router connection is going to be something .1. So I've got 3 different networks here, but I've got to come up with an IP addressing scheme for these connections here. So before we use the /30 subnet mask, that gives us 2 usable connections. I'll just start 0.0/30. I'm going to put those there. So what is the network address, first usable IP, last usable IP, and broadcast address there? Well, you can do it in your head, or you know what? Let's just use the cheater way. 192.168.0.0/30. So I'm going to calculate this. So what does it tell me? My usable host range is 192.168.0.1 to 0.2. Okay, so I'll assign 192.168.0.1/30 to my accounting router for that interface, and I'll assign 192.168.0.2/30 to the interface on the other side. Now, packet tracer gets a little bit messy here, but we'll get it. So 192.168.0.0 is my network address. The first usable IP I'm assigning to S001, and 192.168.0.2/30 I'm assigning to S000 on the other router. Now the broadcast address is 0.3, so I add 1 to that, and that's where I get the start of my next network. Let's see, I'll try to tighten these labels up. It's going to be a little bit messy here. I'm trying to fit everything on my screens so we can see all the information at once. So for the network here between my admin router and research router, I'm going to use the 192.168.0.4/30 network. So for specific IP addresses, you can use the calculator, or I can figure it out in my head. 192.168.0.5/30. And here I've got 192.168.0.6/30 for those interfaces. It's getting a little messy, but we're doing all right. So I've got, again, the network address, and then the specific IP addresses for those interfaces. Writing down the network address is just going to make configuring OSPF a little bit easier for me. So we should be able to follow the pattern. So we see here we went 0, 4, what comes next? 192.168.0.8/30. That's the network address. And so for the specific interfaces, I'm going to use 192.168.0.9. And it really doesn't matter which side I assign which IP address, as long as I know I'm doing 192.168.0.10/30. Alright, so that'll be S00. I think my labels are in an okay spot where everything is making sense. Try to put every IP address label close to its interface. And if you move anything around in Packet Tracer, it all just falls apart. But there we are. Alright. Just going to straighten things up a tiny bit, just so we can fit as much as we can in our workspace. Okay, so this is my network diagram. My network diagram is complete. However, I have not configured anything on the PCs, switches, or routers. So I'm going to close my subnet calculator. And let's think about how we need to do this. Now, I've got a cheat sheet. At the end of the book, we've got a command cheat sheet with Linux, Cisco, routers set up, a bunch of different stuff, just kind of collapsed into different sections. Like if you don't know how to set up OSPF routing, I can click here and I can remember the commands, what they're supposed to look like. Samples. Can't just use the cheat sheet blindly without knowing what these commands actually do. You have to know what you're supposed to do. So feel free to use the cheat sheet to configure everything, to configure interfaces, spanning tree, we'll talk about trunking and VLANs, assigning IP addresses, etc. I'm just going to bring up my PCs first. I'll do those. Come to the IP configuration, 10.0.3.5. Now I've got to correct the subnet mask because I want /24. My default gateway should be 10.0.3.1. That's pointing to my router, gigabit 00 interface. That looks good. I'm going to bring up research, IP configuration. My IP address is 10.0.2.5, and I'll fix this. 10.0.2.1 would be my default gateway. And over here, my PC admin, I'll change its IP address to 10.0.1.5. Fix that subnet mask. 10.0.1.1. So my PCs are fully configured. They should be good to go. Now what should I change on my switches? What do I need to change here? So let's come to the CLI. Let's try something. Let's launch Notepad. Alright, I've got Notepad here. Let's do a little test. Let's see if we can do Cisco commands in Notepad and just paste everything in and see if it works. So what do we do to configure the switch? En, enable, config t, host name. I'm doing S accounting right now, so I'll name it to match the label. S enable secret Cisco. What else are we going to configure here? Banner, MOTD, keep out, line con 0, logging synchronous, password class, login exit. So that's some basic security stuff. We want to protect our switches so that bad people don't do bad things here. Here's what I'm going to do. I'm going to copy this. I'm just going to paste this right here. Paste. Did it work? Yes. So essentially all those commands would just run on my switch. The host name got updated. I protected the enable command. I protected my console port. So that's good. So S accounting is done. So what's the benefit of doing that? Well, let's look at S research. So what's the difference? Like, the only thing I'm going to change here would be S research. Select all, copy, paste it in there, and bam, that switch is configured. I only had to change one tiny thing. That switch is good to go. So let's come to S admin. Enter, just paste, Control B. Doesn't work so well in Packet Tracer, typically. But now that switch is pretty good. Alright, so I'm pretty happy with my switches right now. I could change spanning tree to use Rapid PVST+. I don't have any switches connected to other switches though, so that wouldn't really help me out at all. That is another possible configuration I could do, but I've got no loops between switches. I'll keep Notepad around. I'll drag it off to the side. I've got to configure my routers though. So how would I configure router accounting? I almost said router 1. I have no router 1. R accounting. We still would use the enable secret, use the banner, change that. But now we need to configure our interfaces. So how do I configure an interface? You can use the cheat sheet, although it's up there right now. Int G00. I have to give it an IP address. I'm giving that 10.0.3.1. Can't use the slash notation. No shut. And I have to configure my serial interfaces too. Int S001. Oops, typo. IP address. So 001 is 192.168.0.1, 255.255.255. What? If you remember, 252. That's the decimal notation of /30. No shut, and I see the clock here, so that's the DCE side. So we're going to change the clock rate to 128,000. I also need S00. So let's do what every professional does and just copy and paste and change what we need to. 9, same subnet mask. It's another DCE size, so I do have to set the clock rate. So that's good. Now let's think about OSPF. For this router, I need to set up OSPF. So let's come down here. I've got a section just on setting up OSPF routing. So there's the command. After I do that, I'm gonna exit here to exit out of the interface configuration to get back into regular config mode. I'll say router OSPF1 network. So I'm gonna, how many cables do I have connected here to this router? I've got 3, right? I've got 3 cables. That means I'm gonna need 3 network statements. I've got the 10.0.3.0. I have to use the wildcard mask over there, area 0. I've got the network 192.168.0.0. Use the .3 wildcard, area 0. Network 192.168.0.8. I'm not going to change my router ID. I don't have to, so I'm not going to. It's optional. Can be helpful if nothing's working. You can give your router a router ID and start troubleshooting. All right, let me see. I'm just going to double check my commands. Interface G00, 3.1, 001 will be 0.1. That's good. Clock rate 0.9. I think everything looks correct. So I'm going to copy all that. I'm going to come to router accounting. Continue with the configuration dialog. No. Press return to get started. All right, let's see if it runs correctly. I'm going with no notes right now. Paste. Okay, a whole lot of stuff happened. Hopefully it worked. Okay, so I did this on R accounting. Should work. If not, we'll troubleshoot later. I'll troubleshoot it just the way I would actually troubleshoot it with you. I'm gonna copy and paste. What should we do next? Let's do research next. So my host name is going to be different. The enable secret, keep that the same. All that stuff is good. G00, what's my IP address? It should be 2.1, right? So S001 will be 192.168.0.6. That's not a clock rate. Neither of these are DCE connections, S01 or S00. S00, I need 0.10 for the IP address. And I need to change my network commands here. So the research router knows about the 10.0.2 network. It knows about the 0.8 network over here, and it also knows about the 0.4. So I need to change that one. So I'm going to copy that. Click on research, come to the CLI, continue with the configuration dialog. Nope. Turn to get started, and oh, son of a gun. Control-Shift-6, that's the cancel. Name lookup aborted. I copied too much. Oh, I copied way too much. Did I do Control-A copy? No, I just need this part here. Bad things would have happened. All fixable, but bad things. Okay, so I paste that in. I see some green blinky lights. That's good. I also saw some status messages change over on the left here. We're seeing some other. We saw an adjacency change. That means OSPF is starting to work. It's magic. So that is good. Now I need to change our admin's configuration. So I'm going to, I'll copy the first one I did. I'll copy accounting's. So fix the host name to admin. come down, all that's good. So my G00 is going to be 10.0.1.1. S001, let's find that. It should be 0.5. And the clock rate, I should be setting it there, so that's good. S00 should be 0.2. And I do not need the clock rate there. Now this router knows about 3 networks also, but going to be some changes. It knows about the 10.0.1.0 network. What else does it know about? It knows about this one. It knows about 0.0, and it knows about 0.4. So I've got 0.0. I need to change this to 0.4. Copy that. Bring up our admin CLI. I'm going to paste this in. And I have to hit enter one more time because I didn't paste the carriage return in there. Okay. I've got a bunch of green blinky lights. That's good. I can see that my routers are exchanging information. That's good. So what should we test first? Basically, my configuration's done. I've got my network cabled. I've got the IP address. I came up with an IP address configuration. I changed the configuration of the PCs. I configured my switches. I configured my routers. Let's see. I'm nervous. It's going to work the first time. Ping 10.0.1.5. So this is my PC in accounting. I'm going to try to ping the PC in the admin building. Sometimes the first time you ping, the first request might time out, but we did get a reply, so that's okay. So here, 4 sent, 3 received, 1 got lost. It's not because I configured anything improperly. It's just, that just happens sometimes. It's okay. If I ping it again, they'll all be successful. Any ping from that to that IP address, they'll always all be successful. What about the research building? Whoops, that's the wrong IP address, not 21, 10.0.2.5. So it's kind of figuring out where it is right now. First one timed out, but then we get a reply. That is good. You know what it looks like? Everything is working. So from my accounting PC, I should be able to ping every IP address on here. So let's ping this interface. 192.168.0.6. Ping 192.168.0.6. So why did I pick that one? Well, it's not on the accounting PC's local area network. It's not connected to my accounting router, and it's not on the same network as PC admin, so it's just another one that we need to try to get to. Reply. Yay, it's working. Really, we should be able to ping everything. Should be successful at this point. You can try all sorts of connectivity. I'm glad that it worked, to be honest. What if it didn't work? What would I do? If my ping's blocked? Well, of course, if you're working with Windows computers, make sure you disable your firewall temporarily. Make sure that you've configured the IP address on the correct wired interface. I would come to my routers if my pings still aren't working, and I would want to check. Can this accounting router ping the admin router's interface locally? So what would I do here? I'm in config mode, so I'm going to run do ping 192.168.0.2. So I have to see if this connection is actually working. And it is, so that's good. So I would check all of these connections, router to router, make sure those are up. If they are up, make sure that every one of your PCs, make sure that they can ping their default gateway. So this is my PC accounting. I would want to ping 10.0.3.1. If your PC can't ping its default gateway, nothing's going to work from that PC at all. So all the direct connections, every PC on the same local PC and router interface in the same subnetwork, they should be able to ping successfully. If all those pings are successful, what would I want to look at next? Well, I'll pull up this router. I'm going to do a visual inspection first. See if your lights are blinking green. If they're not, that's a problem. A lot of times, because the router interfaces come down out of the box, factory fresh, turned off, some people give these interfaces IP addresses, but they don't issue the no shut command, so they're not actually active. So how would I check that? Look at the green blinky lights on the physical hardware, or run do show IP int brief, and you can see what's up, what's down. Like here, I'm not using G01, so that's administratively down, that's fine. Everything else, serial 000, 001, and G00 should be up, and the IP addresses should be assigned and should be correct. They should match my diagram here. So this looks good, this router's good. I would want to run this command on all three routers to make sure all the interfaces are up. I would also want to run do show IP route to look at the routing table. Now I should see all of my networks here. I've got all of my 10 dot networks. So this is the accounting router. It knows about the 10.0.3 network because it's local, it's connected. It learned about the 1.0 and 2.0 through OSPF, so that's good. I also see the internal, the 192 networks. I see all three. So I see 0.0, I see the 0.4, and I see 0.8. Two of them show up in my routing table because they are local, but the third one, the network that connects our research to our admin, 0.4, you can see from the key that it learned, my accounting router learned about this via OSPF. So if something's not working in my routing table, if I don't see a network in my routing table, something's wrong. I may need to run do show run and just take a look at the network statements that I issued to make sure that they're correct. If there's a typo in my wildcard mask or in the network address, like I use an IP address instead of a network address, that could be a problem that I have to fix. If I messed up the area, I would need to fix that too. All things that you would want to look into. So use ping heavily, use those commands, do show IP route, do show IP int brief. Use those commands heavily to try to figure out what's going on and make sure everything works. So I've used dynamic routing, I've shown my IP addressing scheme in my network. I connected via the uplink ports. I did all that. I did all this stuff. So I cabled the network. You'll have to connect the PuTTY. You have to reset everything. Use the cheat sheet if you need help with commands or refer to previous labs. We configured the router interfaces we checked, and we set up OSPF. So this is a challenging assignment because I do not specifically give you all the commands that you need to run. Previously, I just say essentially run this next, run this next, run this next, and you just kind of follow along. This is a good exercise for putting it all together. So I essentially started from scratch and I implemented it a way that made sense to me. Now, when you do this, you can pick different subnets. There are many different subnets that would work, different schemes. You could do some slightly different configurations, but this is basically the process that you would want to follow to define your network first and then go through and implement your network by configuring all the hardware. So I hope this is valuable. It's challenging. I realized the first time you go kind of without the net, without the safety net of me telling you exactly what to do. But make sure that you understand the process and what we've done to this point.